Okay, so we're going to look at algebraic solutions. We've done graphing solutions, and we've graphed it and determined is the solution under or above the parabola. Going from this to an algebraic solution, all we're doing is looking at the x-axis. So in this case, the solution is on the lower part and the upper part, but not through the middle. So we look at the solution, anything under x or greater than 1. So how do we find this without graphing? So what we do is we find the x-intercepts, and then we check, is the inside the solution? And if it is, everything inside between the intercepts is a solution. If it's not, then the outside is the solution. So another example, we've got the inside of the parabola shaded, or greater than the parabola. If we look at the x-axis, between the intercepts is the solution, the outside is not. In this case, set interval, -6 is less than or equal to x less than or equal to y. X is anything in the middle. So two other possible examples. We could have this one where we've got one intercept. And so this one is tricky because it could be one solution, x equals 3, or it could be all real numbers except does not equal 3. Oh, that's -3. So if the under the parabola is shaded, then everything except 3 is a solution. This one here could be nothing or everything. So in this case, if the shaded part is above the parabola, nothing is a solution. None of the solution is touching the x-axis. If the underneath part is shaded, then everything, all real numbers, is a solution. So you always have to check, is it one or is it the opposite? So we've already learned this. We are going to look at the quadratic, and using factoring or quadratic formula, we're going to get the intercepts. So finding the algebraic solution. Step 1 is find the x-intercepts. So we're going to check if we can factor, always much easier if we can. And we find that 3 and 6 add up to 9, multiply to 18. We're going to make this 0 because we know it's on the x-axis. And so we solve for the intercepts. Now, for the intercepts, we don't have to worry about the inequality. We know that it's going to be at this point. We just don't know which side it's going to be. Now, you might look at this and go, well, it's got to be on one side. It won't work for both. So we've got to find the intercepts, then use those to check. So now what we're going to do is, we've got the two numbers. We have to check something either in between or on the outside. I always recommend 0. 0 is the easiest thing because everything turns to 0. Now 0 is on the outside, so I'm going to write that down so I can remember. So go back to my original. The y is 0 and all the x's are 0. This is 0 because we're on the x-axis, and we chose x equals 0. And we get to this point. 0 is greater than 18. Now hopefully you go, wait a second, 0 is not greater than 18. This is false. So write that down. We checked the outside. We checked x equals 0. It's false. So the answer is inside. Let me explain that one more time. We checked the outside, but the outside didn't work. So the outside is not the solution. The solution is inside. Now inside is between these two. And I write my answer. X is anything in between these two. The inequalities always face the bigger number. And if you're not sure what goes here, go back to the original part. We have no equal sign, so I'll have no equal sign in the answer. So the next one is already factored. So just remember we're finding the intercepts, so we get the solution from each one. Check whether it's inside or outside, and then write the final solution. So for the x-intercepts, we make this 0. And just for now, I'm going to make it an equal sign because we're finding the intercepts. Now this negative, we can ignore it almost. If I divide by -1, 0 divided by -1 is still 0. And then I get my two solutions, -3 and +2. So from there, we're going to put the two numbers, and we need to figure out, is the solution inside or is it on the outside? So I always check 0. And one note, if 0 is one of the factors, one of the intercepts, you cannot use 0. You have to pick something like maybe 1, 2, something else. 1 is probably the easiest of the. And 0 is in the middle, so I'm going to write down inside so I remember at the end. So I go back to my equation. Y is always 0. And if I plug all this in, +6. 0 is great. Actually, that's false. So we check 0. It's inside, and that's false. So the inside is not the solution, which means we need to show that the outside is the solution. We have two different pieces. X is less than -3, and x is greater than 2. And one thing we need to check, we go back to the original and we have an equal sign in the original equation. So I need equal signs on both of these inequalities. So find the intercepts, check 0, whether it's inside or outside, and then find the solution based on that. So the last one, we're going to look at it to find the x-intercepts. So we can do nose hairs because we have a hard trinomial, but in the end, if you have something that looks more complicated, just go straight into quadratic formula. And it's not a perfect square, which confirms that we would have to factor or use the quadratic formula. So we're going to start by plugging in -7 plus √109 divided by 6, and we get 0.6. So because we're graphing this, we are going to, not graphing, but putting on the number line, we're going to put into a decimal. If I do -7 minus √109, I get -2.9. So now we have to check, is the solution inside or on the outside? So I'm going to put the smaller one and the bigger one. 0 is in the middle, so I'm going to check 0, like I always do. And it's inside. So I write that just to keep track of it. Go back to my equation. Y becomes 0. 0 plus 0 minus 5. And this is true. 0 is greater than -5. So if this is true, that means the inside is true. That means the solution is inside the two boundary points. And the boundary points are the x-intercepts. So in this case, the solution is -2.9. It's less than x. X is less than 0.6.